No animal on Earth can survive an open winter as cold as the ones humans have lived through for tens of thousands of years. And it isn't because your body is tougher than a wolf's, or a bear's, or a musk ox's. In a straight biological contest against the cold, you lose. Every time. So how do humans end up living through winters that would kill almost every other mammal on the planet? The answer isn't biology at all. It's architecture. And it's a trick so simple, so easy to overlook, that most people walk past examples of it every single day without ever noticing what it's actually doing. Let's start with the uncomfortable truth. Compared to nearly every animal built for cold climates, the human body is a poor match for extreme winter. You have thin skin, minimal natural insulation, and none of the specialized adaptations that keep an Arctic fox or a polar bear alive through months of brutal exposure. A wolf can curl up in open snow and sleep through a blizzard. A human left in the same conditions, with no tools and no shelter, would be dead well before morning. And yet humans didn't just survive the coldest environments on the planet. They thrived in them, raised families in them, built entire cultures inside them, for far longer than most animals have needed to specialize for cold at all. The gap between what your body can handle and what your ancestors actually lived through is enormous. Something had to fill that gap. That something was shelter, but not shelter in the vague sense of a place to hide from the wind. Something far more specific, far more deliberate, and far more clever than most people give it credit for. Here's the trick. Instead of trying to out-engineer the cold with a body that could never win that fight, humans changed the actual shape of the space around them. They built structures that didn't just block wind. They built structures that manipulated how heat moved, using geometry itself as a survival tool. Researchers studying traditional cold climate shelters across multiple cultures, from Arctic snow houses to semi-underground pit dwellings used in parts of Northern Europe and Asia, have found a consistent pattern. The most effective cold weather shelters aren't the ones with the thickest walls. They're the ones with the most efficient shape. Think about why that matters. A structure loses heat primarily through its exposed surface area, the parts of it in direct contact with cold outside air. The more surface area a shape has relative to its interior volume, the faster it loses whatever heat is generated inside it. A sharp-cornered, boxy structure has far more exposed surface relative to its interior space than a smooth, rounded one does. This is where the real trick shows up. Domed and rounded shelters, the kind found across multiple unrelated cold climate cultures with no contact with each other, consistently minimize exposed surface area for a given amount of interior space. Which means for the exact same amount of body heat generated inside, a dome-shaped shelter loses that heat more slowly than almost any other shape you could build. Multiple, completely separate human cultures arrived at the same rounded geometry independently, not because they copied each other, but because the physics only allows for one efficient answer. That's remarkable on its own, but the trick goes deeper than shape alone. Many traditional cold climate shelters were also built partially or fully below ground level. Semi-underground pit houses, used by cultures navigating brutally cold winters, take advantage of a fact most people never think about. Once you dig even a few feet into the earth, the ground itself acts as a massive, stable thermal buffer. Soil several feet down stays at a far more consistent, moderate temperature year-round than the air above it ever does, insulated by the sheer mass of the earth surrounding it. By building downward instead of only upward, these cultures essentially borrowed the Earth's own natural insulation, using the ground itself as an extra layer of wall that never needed to be built by hand at all. Combine that with a rounded or domed roof structure above ground, and you get a shelter that fights the cold on two fronts simultaneously. Minimal exposed surface area up top, where wind and open air do the most damage. Natural geothermal buffering below, where the Earth quietly holds a stable temperature no human effort was required to create. Researchers examining the thermal performance of these traditional structures have found that even with only a small fire or a handful of body heat sources, a well-built underground or dome shelter could maintain interior temperatures dramatically warmer than the outside air, sometimes by several dozen degrees, using a fraction of the fuel a modern above-ground structure of comparable size would require. This wasn't luck. This wasn't primitive guesswork stumbled into by accident. This was applied physics, refined generation after generation, encoded not in textbooks, but in the exact curve of a wall and the exact depth of a dugout floor. Compare that to how animals solve the same problem, because the contrast is genuinely striking. Animals built for the cold solve it almost entirely through biology. Thicker fur, layers of blubber, metabolic adaptations that let them slow their systems down through the harshest months. Every adaptation lives inside the animal's own body, fixed by genetics, refined over an evolutionary timescale that spans hundreds of thousands of years per meaningful change. Humans solve the exact same problem almost entirely outside the body. Instead of waiting for evolution to slowly build a thicker coat over hundreds of generations, humans change the environment around their bodies within a single generation, then pass that solution down through teaching rather than through DNA. That distinction matters more than it might seem. A polar bear's insulation took an enormous span of evolutionary time to develop and can't be meaningfully improved within one bear's lifetime. A human shelter design could be adjusted, improved, and retaught within a single winter, based on what worked and what didn't the year before. This is worth sitting with for a moment because it reframes the entire competition. A polar bear alive today carries insulation shaped by ancestors going back hundreds of thousands of years, an inheritance it had no say in and cannot meaningfully edit. A human family building a shelter one winter could notice condensation forming in the wrong corner, adjust the curve of the wall the following season, and pass that small correction down as a piece of practical knowledge within a single lifetime. One system runs on the glacial timescale of genetic mutation and natural selection. The other runs on the comparatively lightning-fast timescale of observation, trial, and memory. Humans essentially found a shortcut around the slow, brutal machinery of biological adaptation. Instead of re-engineering the body, they re-engineered the space immediately surrounding it, and did so at a speed no animal's biology could ever match. That's the real trick hiding inside these shelters. It was never really about walls keeping wind out. It was about a species using geometry and applied physics to compete on a battlefield extreme cold, where its own body had almost no natural advantages at all. There's a further wrinkle here that makes the whole picture even more interesting. Because this solution lived outside the body, in shared structures and shared knowledge rather than in genes, it could also be transmitted sideways, not just down through generations, but across entire communities in the same season. A design improvement discovered by one family in one settlement could, in principle, spread to neighboring groups long before it would ever have had a chance to spread through interbreeding and genetic drift. Biological adaptation is locked to lineage. Architectural adaptation isn't locked to anything except the willingness to watch, learn, and rebuild. There's something almost humbling about that when you really sit with it. Every other creature that survives brutal cold does so because its body was shaped by that cold over an almost incomprehensible stretch of time. Humans survive the exact same cold by refusing to wait for that process to happen at all and building an answer instead. Consider what this actually implies about the relationship between a species and its environment. Nearly every other animal on the planet is, in a very real sense, a product of its climate. Its body is a physical record of thousands of generations spent negotiating with cold, heat, drought, or altitude, encoded directly into fur density, fat distribution, lung capacity, blood chemistry. The environment writes itself into the animal, slowly, patiently, over spans of time no single creature could ever witness. Humans quietly broke that rule. Rather than letting the cold write itself into human bodies over hundreds of thousands of years, humans wrote a response back into the environment instead, in the shape of a wall, the depth of a dug floor, the curve of a roof. The relationship flipped. Instead of climate shaping the species began shaping small pockets of climate for itself, one shelter at a time, faster than biology could have ever managed on its own. You can still see fragments of this exact same trick today, even if you've never noticed it. Rounded architecture in cold regions. Partially underground structures used for consistent temperature control, sometimes marketed today as an energy-efficient building technique, without much awareness that the underlying principle is tens of thousands of years old. Even something as simple as an igloo diagram in a children's book is a direct descendant of an idea that let an under-equipped, thin-skinned species outlast animals that were, on paper, built for the cold in every way humans were not. It's worth remembering, too, that this trick didn't require a written language, a formal understanding of thermodynamics, or anything resembling modern engineering education. It required careful observation, passed carefully enough between people that a mistake in one generation's wall could be corrected in the next. That's not a small thing. That's an entire alternate survival strategy, invisible in the fossil record in the way biological adaptation is visible, because it lives in behavior and structure rather than in bone. No animal on Earth can survive an open winter as cold as the ones humans have lived through for tens of thousands of years. Not because the human body earned that ability, but because humans figured out, long before written history, that if your body can't win the fight against the cold, you don't have to fight it with your body at all. You just have to build something smarter around it. And maybe that's the real inheritance worth noticing, underneath all the walls and domes and dugout floors. Not a specific technique, but a habit of mind. When the body reaches its limit, look outward instead of waiting for the body to change. That habit didn't stay confined to shelter. It shows up in clothing, in tools, in fire, in every place humans have quietly refused to let biology be the final word on what they could survive.